Good evening, students. How are you all? Welcome to the next session of quadratic equations. I'm Kanika ma'am, your mathematics teacher. So till now, we've covered the entire chapter of quadratic equations. We've covered all the concepts. In today's class, we are going to discuss a few questions, and these questions, they are based on past papers. So let us now start. Now, this is the simplest one. If 1 by 2 is root of the equation x square plus kx minus 5 by 4 is equal to 0, then find the value of k. So here we know 1 by 2 is root of this equation. That means if you replace x by 1 by 2, this is going to satisfy this equation. So we have x square plus kx minus 5 by 4 is equal to 0. We'll replace x by 1 by 2. We'll get 1 by 2 square plus k times 1 by 2 minus 5 by 4 is equal to 0. So this can be written as 1 by 4 plus k upon 2 minus 5 by 4 is equal to 0. Here we have the LCM 4, and this can be written as 1 plus 2k minus 5 is equal to 0. This 4 will go on the other side and will get multiplied with 0. So we will get 1 plus 2k minus 5 is equal to 0. This will give us 2k minus 4 is equal to 0. This 1 minus 5 will give us minus 4. So we have here 2k is equal to 4. Finally, we have here k as 2. So k is the required value here. K is equal to 2 is the required value of k. So let us now discuss a similar one. If x square plus 2kx plus 4 is equal to 0 has a root x is equal to 2, then find the value of k. We know x equal to 2 is root of the equation. That means if we put x is equal to 2, this is going to satisfy this equation. So we have x square plus 2kx plus 4 is equal to 0. We will replace x by 2. We will get here 2 square plus 2k into 2 plus 4 is equal to 0. So we have 4 plus 4k plus 4 is equal to 0. That means we have 8 plus 4k is equal to 0. This 8 will go on the other side. We will get here minus 8. So we have 4k equal to minus 8. That means we have k is equal to minus 2. So the required value of k here is minus 2. Now coming to the next one. So this one is quite different. Here we have square root of 2x plus 9 plus x is equal to 13. Now in such questions, we keep the square root term on one of the sides and all other terms on the other side. So here we can take this x on the right hand side. This will become minus x. So we'll get here square root of 2x plus 9 is equal to 13 minus x. Now in order to get rid of the square root sign, we are going to square both the sides. So we will get here square root of 2x plus 9 whole square is equal to 13 minus x whole square. So this will give us 2x plus 9. And here we are going to apply the identity of a minus b whole square. That will give us a square plus b square minus 2ab. So this will give us 2x plus 9 is equal to 169 plus x square minus 26x. Now these terms we are going to take on the other side and the signs will get reversed. So we will get here 169 plus x square minus 26x minus 2x minus 9 is equal to 0. So this can be written as x square. I'm writing x square as it is. And here we combine these two terms. We will get minus 28x. And 169 minus 9 will give us positive 160. Now we have equation x square minus 28x plus 160 is equal to 0. We can solve this by factorization method. We want two numbers whose product is 160 into 1. 160, that's the constant, multiplied by the coefficient here, that's 1. 160 into 1, that is 160 itself. and we want the sum as minus 28. So if we take minus 20 and minus 8, that is going to give us the sum minus 28 and will give us the product 160. So this can be written as x square minus 20x minus 8x plus 160 equal to 0. Now we can take x common from here. We'll be left with x minus 20. And from here we can take minus 8 common. We'll be left with x minus 20 here. Now we can see here x minus 20 is common. And then we have x minus 8. From here we can say either x minus 20 is equal to 0 or x minus 8 is equal to 0. Or we can say either x is equal to 20 or x is equal to 8. Now, if we put x is equal to 20 here, this is not going to satisfy the equation. So, we will reject this. So, x equal to 20 does not satisfy the given equation. Therefore, we are going to proceed with x is equal to 8. So, we can say that x equal to 8 is the required solution. I hope students this question is clear to you. We'll solve a similar one also. So this is similar to the previous one. We have square root of 6x plus 7 minus 2x minus 7 is equal to 0. We are going to keep the square root on this side and we'll take this on the right hand side. So if we take this on the right hand side, the sign will get reversed. It's minus here. We are going to make it plus now. So it's square root of 6x plus 7 is equal to 2x minus 7. Now, in order to get rid of the square root sign, we'll square both the sides. So, we'll get square root of 6x plus 7 whole square is equal to 2x minus 7 whole square. Now, this will give us 6x plus 7 and here we can open the bracket using the identity a minus b whole square. So, this is a square plus b square minus 2ab. So this is 6x plus 7 and this will give us 4x square. This will give us 49 and this will give us 28x. Now we are going to take this on the other side. Their signs will get reversed. So we have 4x square plus 49 minus 28x minus 6x minus 7 is equal to 0. Now this will give us 4x square and then we can combine these two and we'll get here minus 34x. Minus 34x. 49 minus 7 will give us positive 42. As we can see here, we can divide this 2 out by 2. We'll write this as 2x square minus 17x plus 21 is equal to 0. Now we are going to solve this by factorization method. We want two numbers whose product is 21 into 2. That is 42. And then we want the sum as minus 70. So if we take minus 14 and minus 3, that is going to give us the product positive 42 and will give us the sum minus 70. So this will become 2x square minus 14x minus 3x plus 21 is equal to 0. From here we can take 2x common and we'll be left with x minus 7 and we'll take minus 3 common and we'll be left with x minus 7 here. Now here x minus 7 we can take common and we have 2x minus 3 is equal to 0. So we can say either x minus 7 is equal to 0 or 2x minus 3 is equal to 0. That means either x is 7 or x is equal to 3 by 2. Now, if we are going to put x is equal to 3 by 2 here, it will not satisfy the equation. So, we are not going to consider this. Therefore, x is equal to 7 is the required value of x here. So, we will reject here x is equal to 3 by 2 since it is not satisfying the equation. Thus, we can conclude x equal to 7 is the required value of x. I hope students this question is clear to you. Now let us discuss the next question. Find the value of m for which roots of the equation mx 6x plus 10 plus 25 is equal to 0 are equal. Now here, before we do anything else, we are going to first take this mx and we multiply this inside bracket. We will get here 6mx square plus 10mx plus 25 is equal to 0. Now we want that value of m which is going to give this equation real and equal roots. For that we need the discriminant to be equal to 0. So we are going to first compare this with ax square plus bx plus c equal to 0. So here we have a as 6m, b 10m and c 25. So we want the discriminant to be equal to 0 since we want the roots to be real and equal. That means we want b square minus 4ac is equal to 0. So b square here is 10m square minus 4a, that is 6m, into c, that is 25. Now this will give us 100m square. 4 into 6 is 24. 24 into 25 will give us 600. 600m is equal to 0. Now we can divide this throughout by 100 and we'll get here m square minus 6m is equal to 0. We can take m common and we'll have m minus 6 inside bracket. So from here we can say either m is 0 or m minus 6 is equal to 0. If we take m is equal to 0, this entire term will become 0 and we will get 25 is equal to 0, which is not true. So we'll reject m is equal to 0. We'll reject this and now we have m minus 6 is equal to 0. That means m is 6. So the required value of m here is 6. I hope students this question is clear to you. Now coming to the next one. One root of the equation 2x square minus 8x minus m is equal to 0 is 5 by 2. Find the other root and the value of m. So this equation is given to us and we already know 5 by 2 is root of the equation. We are going to first replace here x by 5 by 2 and accordingly we'll solve for m. So we have 2 into 5 by 2 square minus 8 into 5 by 2 minus m is equal to 0. This will give us 2 into 25 upon 4 and this will give us 8 into 5 will give us 40. 40 upon 2 minus m is equal to 0. Now this will give us 50 upon 4 minus 40 upon 2 minus m is equal to 0. We can take the LCM here. The LCM here is 4. We will get 50 minus 80 minus 4m upon 4 is equal to 0. 4 we are going to take on the right hand side. It will get multiplied with 0 and it will become 0 then. So we have, and also 50 minus 80 will give us how much? Minus 30. So this we'll get minus 30 minus 4m is equal to 0. Now we'll take this minus 30 on the right hand side. It will become plus 30. So we have minus 4m is equal to 30 here. This minus 4m we'll take in the denominator here. We'll get m is equal to 30 upon minus 4. And when we'll simplify, we'll get m here as minus 15 upon 2. So the required value of m we have minus 15 upon 2. Also, we have to find other root of this equation. One of the roots is already given to us, 5 by 2. We have to solve for the other root. In the next step, we'll replace this m by minus 15 by 2 because we've solved for this. So we have 2x square minus 8x plus 15 upon 2. X square minus 8x plus 15 upon 2 is equal to 0. Please notice here, we have m as minus 15 by 2. It's minus 15 by 2. That means minus minus will become plus here. So this will give you plus. So now we have, we can multiply this throughout by 2. We'll get 4x square minus 16x plus 15 is equal to 0. Now we are going to solve this by factorization method. So we want two numbers whose product is 15 into 4, that is 16. We got 15 into 4, that is 60. And we want the sum as minus 16. This is the sum. If we take minus 10 and minus 6, this is going to give us the sum minus 16 and will give us the product positive 60. So here we split the middle term. We will write the first term as it is. Minus 16x can be written as minus 10x minus 6x, and this 15 we are writing as it is. There's no change here. Now we can take 2x common here. We'll be left with 2x minus 5. From here we can take minus 3 common and we'll be left with 2x minus 5. Now this 2x minus 5 is the same. There's no change here. And then we have 2x minus 3. We've taken 2x minus 5 common here and we are left with 2x minus 3. So x is 5 by 2 here, or x is 3 by 2. X 5 by 2 was already given to us in the question. So the other root here is 3 by 2. So this is the required root. I hope students this question is clear to all of you. Now coming to the next one. Find two consecutive odd natural numbers, sum of whose squares is 130. We want two consecutive odd natural numbers. So we are going to take the natural numbers as 2x plus 1. Please notice we want odd natural numbers. That is why we have taken 2x plus 1. And since we want consecutive odd natural numbers, the next one would be 2x plus 3. When we are going to add 2 to this, then we'll get the next odd natural number. Find two consecutive odd natural numbers, sum of whose square is 130. So we know that sum of the squares of these two numbers is 130. Now we can open this bracket. A plus b whole square can be written as a square plus b square plus 2ab. In the same way, we'll open this bracket. We have a square plus b square plus 2ab. And this 130 I'm writing as it is. Let us now simplify this. We will get 4x square plus 1 plus 4x. This will give us 4x square plus 9 plus, this will give us 2 into 2, 4. 4 into 3, 12. 12x equal to 130. Now this 4x square and 4x square will give us 8x square. 4x plus 12x will give us 16x. 1 plus 9 will give us 10 equal to 130. This equal to 130 I have written as it is. This we are going to take towards the left hand side and it will become minus 130. So we have 8x square plus 16x plus 10 minus 130 is equal to 0. So we have 8x square plus 16x minus 120 is equal to 0. Now we can divide this throughout by 8 and we'll get here x square plus 2x minus 15 is equal to 0. Please notice 8 divided by 8 will give us 1. 16 divided by 8 will give us 2. And 120 divided by 8 will give us 15. So this is x square plus 2x minus 15 is equal to 0. Now we are going to solve this by factorization method. So we want two numbers whose product is minus 15 and the sum we want positive 2. If we take positive 5 and minus 3 here, this is going to give us the product minus 15 and will give us the sum positive 2. So this will give us x square plus 5x minus 3x minus 15 is equal to 0. We have written this 2x as 5x minus 3x. Now from here we can take x common. We'll be left with x plus 5. And we'll take minus 3 common from here. We'll be left with x plus 5. Now here x plus 5 is common. And then we have x minus 3 here equal to 0. From here we can conclude either x plus 5 is equal to 0 or x minus 3 is equal to 0. So we can say either x is equal to minus 5 or x is equal to 3. If we take x is equal to minus 5, that is going to make these numbers 2x plus 1 and 2x plus 3 the odd consecutive natural numbers which we took, these numbers will become negative. So we are going to reject this. We will reject x is equal to minus 5. This is going to make the numbers negative. So we will proceed with x is equal to 3. So right in the beginning, we assume the numbers to be 2x plus 1 and 2x plus 3. So 2x plus 1 is 2 into 3 plus 1. That is 6 plus 1. That is equal to 7. And the next number would be, you can directly say after 7 we have the next number as 9. Next odd natural number as 9. Or you can solve from here 2x plus 3. That is 2 into 3 plus 3. That is 6 plus 3. That is 9. So the required numbers here are 7 and 9. I hope students this question is clear to all of you. Now coming to the next one. The sum of two numbers is 11 and sum of their reciprocals is 11 upon 28. Find the numbers. So we have two numbers whose sum is 11. So we can take the numbers as x and 11 minus x. Sum of two numbers is 11. That is going to help us to get the numbers. One of them is x. The other one would be 11 minus x. Now, sum of their reciprocals is 11 upon 28. Sum of their reciprocals is 11 upon 28. We'll take the reciprocals here. We have 1 upon x here. 1 upon 11 minus x here. We'll add these two. We'll get 11 upon 28. Now, we'll take the LCM. We'll get 11 minus x plus x into x into 11 minus x is equal to 11 upon 28. Please notice here we have taken the LCM. That's how we've got in the numerator 11 minus x plus x, and in the denominator we have multiplied. We've got x times 11 minus x. That's 11 upon 28. Now we can cancel out minus x and plus x. So these two will get cancelled. And we will have 11 upon x into 11 minus x equal to 11 upon 28. We can cancel out these 11s and we will have 1 upon x into 11 minus x and 1 upon 28. Now we'll cross multiply this. So when we are going to cross multiply, we will get here x into 11 minus x is equal to 28. This x we will multiply inside bracket. We will get 11x minus x square is equal to 28. This 28 I've written as it is. Now we can take this numbers on the right hand side and we will get here x square minus 11x plus 28 is equal to 0. We've taken these two terms on the right hand side. That is why the signs have got reversed. Now we want two numbers whose product is 28 and the sum minus 11. If we take minus 7 and minus 4, that is going to give us the sum minus 11 and that is going to give us the product positive 28. Now we will get here x square minus 7x minus 4x plus 28 is equal to 0. Now if we take x common, we'll be having x minus 7 here. If we take minus 4 common here, we'll get x minus 7 again. Now x minus 7 here, we have common and then we have x minus 4. So from here we can say either x is 7 or x is equal to 4. Now if x is 7, we know that both the numbers, they add up to 11. So if one of the numbers is 7, the other one would be 4. And if we take x is equal to 4, please notice we have x equal to 4 also. So if one of the numbers here is 4, the other one would be 7, since both the numbers are adding up to 11. Thus, the required numbers here we have are 4 and 7. I hope students this solution is clear to all of you.